Yeah, so you switch the x and y for x, take that constant -5 over. Okay, you have a squared on the y. I want to know what y is, not y squared. And so what's the inverse function to squaring? Right, square rooting. These are inverse functions. Just so if you were cubing, cube rooting, right? So you're going to square root. Can't grab this. Okay, the left and the right, all the way through. And so you get plus or minus square root x minus 5 is equal to y, right? Because the square root of y squared, right? This is y times y, but it's a square root, so if you have a pair, it comes out, right? Okay, so this is your inverse function. That's it. So if I now come to graph, right, so 5, 6, 7, 8, whatever, your next 4 graphs will be 11, 12, 13, 14, then what do I get? The inverse, the regular function is x squared plus 5. The inverse function is plus or minus x minus 5. Okay, you guys have to graph these. And that's why yesterday we went over how to graph vertex form, right? So for 11, we'll do f of x, and we'll put f inverse of x. Okay. Okay, so I have x squared plus 5, which is the same thing as x minus 0 squared plus 5, right? So what's my hk? What's my h? Opposite h, follow k. 0, 5. Okay, so now go 1 unit away, 1 unit away. So what do you want here and here? Are you fine with the negatives on the top or the bottom? Do you care? No? No. Okay, so -1, 1, and then here, what would these two be? -2, 2. Okay, you're going to have symmetry here. You have to graph it. So you throw it in, but remember, okay, here I was being really excessive, but it's really just x squared plus 5. So if I throw in, here I'm just going to throw in the positives. What's 1 squared? 1. And then what's 1 plus 5? 6. Okay, plug in the 2. What's 2 squared? And then what's 4 plus 5? 9, right? Okay, or you can just say, can you see? Yeah. 1 squared plus 5. There's my 6. Go back. Plug in the 2. There's my 9, right? Just substitute. Input, output. That's it. Okay, I'm going to go to graph this. So I grab my... and the numbers aren't big, so we're just going to do increments of 1, okay? So 0, 5, 5, 1, 6, so -1, 6, and then 2, 9, and -2, 5, 6, 7, 8, 9. And so this is my parabola. Okay, remember, we're inverse functioning here. I always recommend you guys put that y equal dash line. Right, so here's my y equal x line, right? And so I'm going to fold it, right? And so even though we don't have it plotted yet, your inverse function is just going to be at that fold. But this is where we get restrictions, which we'll start leading into. Okay, so if I fold it, right, it's now going to become, if I fold it, see how it's upright? Like it's concave up, it's going upward. it's now gonna, when you fold it, it becomes this way. It's lying down, okay? So it's like if I fold it, we're gonna plot it, but you should kind of see visually. If I go to fold it, it's now, see how it's sideways? And now it's no longer a quadratic function, it's a square root function. Okay, all right, so how do we graph the other one? Because you're like, I haven't really covered square root functions, right? Because that's what this is. It's plus or minus x minus 5, and then you have minus x minus 5, and so this is kind of new to you guys. All right, so how do you get your coordinates from a regular f of x function? Don't you just switch the coordinate points, right? Didn't we go over that already? So instead of -2, 9, 9, -2, right? Right, because we switched x for y and y for x. So 6, -1, 5, 0, 6, 1, 9, 2. And you plot those points, and now you have your inverse function. 1, 2, 3, 4, 5, 6, 7, 8, 9, -2, 6, 1, 2, 3, 4, 5, 6, -1, 1, 2, 3, 4, 5, 0. Okay, so here's where there's a problem. And I'm gonna use different colors. Oh wait, did I draw it on there? Yeah, okay. And another color. Yeah, okay. So, okay, this is my original function, which is this. Okay, that x squared plus 5. However, when we go into Desmos, because I'll stop this and then I'll put it into Desmos, you have to type them in separately. In Desmos, you can't do both. This is definitely a restriction, and that's because, do you guys remember that vertical line test that told you whether or not it was a function? It can only cross through once. So if you guys had, right, I'll just make little lines. So we'll do this, we'll do that, we'll do this, and then we'll do this. Okay, so you got your vertical line test. And remember, you guys went through and you made these vertical lines, and if it only crossed the function once, yes, it was a function because it passed the vertical line test, right? This is like middle school. Okay, here you passed it. A line is a function because it only crosses once, right? Here, nothing, nothing, nothing. I do this. No, this is a fail, because a vertical line can't pass the vertical line test. It's not a line because it's not one-to-one. You can only have that one-to-one, right? Okay, here then, it fails it. You cross twice. Okay, but so when you're finding inverse functions, yes, it's a function, but it might have to be a separate of two functions, the positive and the negative. So even though you guys see this sideways quadratic or parabola, there's really two of them. There's the positive one, and then there's the negative. And that's when we start talking about domain and range. So you would still give this to me, but you would recognize that the inverse function is a square root function, and it should be separated positive versus negative. Because of that vertical line test, it will fail it. And so then you're like, oh, it's not a function. It's like, no, it is a function. It's just you separate that positive negative at that vertex, and then it's a function. It's just there's two of them. There's the positive square root and there's the negative square root. So square root functions have restrictions on domain. And then also then the range because of the parabola, because the domain restriction becomes the range restriction. Okay, so 6 is like this. So graph it, fold it, right? Get your table, figure out the switch. And then just know there's a positive and there's a negative. They're two separate. All right. I don't know. Here. There. Okay. All right, let me